In this lesson, I'll show you two examples on how to apply the Euclidean algorithm for finding the greatest common divisor, which is the same thing as saying greatest common factor. Let's begin with question number 1, which asks calculate the GCD of 128 and 58. Now, if you're familiar with this channel, I've already published two other methods on how to find the GCD. So this will be the third. The algorithm starts by first identifying which of the two numbers is larger. We'll set the larger of the two as A and the smaller as B. Next, we'll look to find the remainder of 128 divided by 58. So the top number here, which is our dividend, value A, is being divided by value B, and we're looking for its remainder. To do this, we ask ourselves how many times does 58 fit into 128? And 58 fits twice into 128. 58 multiplied to 2 gives 116. And the remainder will be the difference between 128 and 116, which is equal to 12. So the idea behind the Euclidean algorithm is that the GCD of 128 and 58 is equal to the GCD of the smaller of these two numbers, which is 58, and the remainder that we found, which is 12. Notice that these numbers are smaller, so you could technically find the GCD by analyzing these two numbers, but rather than guessing, let's continue with the process again. Let's continue the cycle until we end up with a remainder of 0. We'll talk about what happens when a remainder of 0 is reached in a moment. And it really helps to organize our work with a table. So I'll say A, B, and R. These are our three columns. A was 128, B was 58, and the remainder was 12. So this time our A value will be the larger of these two, 58 and 12. And we repeat the process. So we'll take 58 and divide that by 12. 12 fits into 58 4 times. Remember, 12 times 4 is 48, and therefore there's 10 as our remainder. Since we didn't get a remainder of 0, we'll continue the process. This time between 12 and 10, the larger of these is 12, that will be our A, and the smaller of these is 10, that will be our B. 12 divided by 10, 10 fits into 12 once with a remainder of 2. Still, we haven't achieved a remainder of 0. So between 10 and 2, 10 is the larger, and 2 is the smaller. So we set those two numbers as A and B respectively. 10 divided by 2 makes 5 with no remainder. So once we've reached the remainder of 0, the previous remainder, which happened to be 2, represents our GCD. So the GCD of 28 and 58 happens to equal to 2, which is also the case for 58 and 12, or 12 and 10, or 10 and 2, and so on. Let's apply this technique one more time for question number 2, which asks us to calculate the GCD of 216 and 234. Of these two numbers, this is the larger, so I'll call it A, and that's the smaller, I'll call it B. So we're looking for the GCD of 234 and 216. We'll set up a chart just like before. We'll say A, B, and R. A is 234, B is 216, and we have to divide them. So that's our dividend, and that's our divisor. 234 divided by 216. It's clear that 216 fits once into 234, and the remainder is 18. You can verify that on your own. So now we're dealing with 216 and 18. We'll repeat the process. 216 divided by 18. How many times does 18 fit into 216? I'll quickly use my calculator. 216 divided by 18, it fits 12 times. Now because it fits 12 times exactly, that means there's no remainder. And so the previous non-zero remainder is our GCD, 18. That's it. That's the GCD of our question. If you need further clarification on this, feel free to use the comment section or view the link to the write-up that is found in the description. Thanks for watching.